Density gives us the ratio of mass to volume. If something is heavy for its size, like a lead brick, the density will be high. If it is light for its size, like a block of styrofoam, the density will be low. It is a physical property. Because it is a ratio, the density is not dependent on the amount of material present. Note the density of water is shown at the bottom of the slide. This slide shows the densities of a number of common substances. Note that the densities for liquids and solids are much higher than that of gases. Also note the different units. Here are two ways to visualize what density is about. The first set of pictures show the relative sizes of 10 grams of water, sulfur, and gold. Note how little space 10 grams of gold takes up. The second set shows the masses of 1 mil, or 1 centimeter cubed, of the same substances. Note the different masses. Here are some things about density you should know. The density of water is 1.00 grams per mil, or centimeter cubed, or cc. The exact density of substance is dependent on its temperature. That is why cold water from a stream goes straight to the bottom when it enters a lake with the warm water on top. Also, if a substance is less dense than a liquid, it will float, while if it is more dense, it will sink. A styrofoam block will float on water, which a lead brick will sink. In which a lead brick will sink. You need to be able to arrange the density equation to solve for density, for mass, or for volume, depending on what you are given. We will do a couple sample problems. This first one is very straightforward. All we have to do is plug the values into the density equation. 12.4 grams of substance that takes up a volume of 13.5 mils has a density of 0.919 grams per mil. This is a review slide. Remember that density is a ratio of mass to volume. Keep your units in mind. When doing problems involving density, you will often have to rearrange the equation. If you have problems rearranging equations, swallow your pride and get some help. The important thing is that you learn to do things right. Also, working with the factor label method ensures fewer mistakes as the units and numbers are laid out in an organized fashion. Here, where we have 60.0 kilograms of trimethyl aluminum with a given density, we want to solve for volume. Notice how easy it is to see that the units cancel and we end up with centimeters cubed, a unit of volume. The purpose of this last slide is to change units to one that makes sense given the scale of the problem. Since 60.0 kilograms of trimethyl aluminum takes up a volume of 80 liters, or about 20 gallons, another calculation would show that it would fit nicely into a few 5-gallon drums. Do that calculation out to show that it will fill 4 drums and you will have only a little liquid left over.